Hi everyone. Today I'm going to show you how to perform the Ramsey reset test in SPSS, where reset stands for Regression Equation Specification Error Test. This is a crucial diagnostic to check if your linear regression model is correctly specified or if you are missing nonlinear relationships like squared terms or cubic terms. First, we need to generate our predicted values. We go to Analyze, Regression, Linear. We move Wage to the dependent box and our independent variables to the independence box. Then we go to Statistics. We check R-squared change and we press continue, and then we go to save, and under predicted values we save the unstandardized predicted values, our y hat variable. We press continue and we press OK to run the model. You notice that SPSS created a new variable called pre-RE1, which stands for predicted by the model 1. And we are going to use this value to run the reset test by creating the squared and cubic terms. We go to transform, compute variable, we move and standardized predicted values to the numeric expression box, and we will create a variable called wage hat 2, and we will raise this variable to the power of 2. We press OK, and we can see that SPS created the new variable. Now we are going to create the cubic terms. We go again to transform, compute variable. Here we change the name of the variable to wage hat 3, and we raise it to the power of 3. We press OK, and we can see that SPSS created a new variable. Now, to run the reset test, we need to see if the squares and cubes of our predicted values can explain our data. So now we can run the formal test. We go back to Analyze, Regression, Linear. We keep our original block 1 and we open a block 2 where we move the variables wage hat 2 and wage hat 3. So by doing this, SPSS will run two models, our initial model and a model consisting of our initial variables plus wage hat 2 and wage hat 3, and we will be allowed to compare both models using the F statistic to see if these new variables are jointly significant. So let's click OK. And now in model summary, we can see that in the line 2, which is the most complete model, which has our new variables, we can see that there's a line called significance of F change, significance of the change in the F statistic. This is an hypothesis test which has under the null hypothesis that our model is correctly specified and the two new variables, wage hat 2 and wage hat 3, are jointly insignificant. We can see by the p-value that we reject the null hypothesis of correct specification, and so the alternative hypothesis that our model is misspecified must stand. We can also see that wage hat 2 does not show up in the list of predictors because the tolerance, the limit for the tolerance, which is a statistics that indicates multicollinearity, was reached. And so wage hat 2 was not even included in our model. So our model is misspecified because we have a problem with the functional form. There are non-linearities that we did not consider and that are relevant to specify the model correctly. So what can we do? We can either include cubic or squared terms, or we can change the form of our dependent variable. Let's do that. Let's go back to Analyze, Regression, Linear, and let's switch wage by the natural logarithm of wage, L wage, and let's run the model again. We will get rid of these variables because they are related to the previous model. And let's check that the unstandardized predicted values will be saved. We press continue. And we press OK to run the model again. So here we can see that there is our predicted values, PRE3, and we are going to create wage hat 2 and wage hat 3 from this variable. So we go to transform, compute variable, we reset our previous values. We will move this new unstandardized predicted values to the numeric expression box. We create a variable called wage hat 2 and we raise it to the power of 2. We click change existing variable, yes. So we have our new variable wage hat 2, and we go back to transform, compute variable, and we create the variable wage hat 3 and we raise it to the power of 3. Here we click in OK, and yes, we changed the existing variable, and now we have two new variables, wage hat 2 and wage hat 3, which are the squared and cubic values of this new predicted variable. So we are going to run the reset test again. We go back to Analyze, Regression, Linear. We create a block 2 and we move our new variables wage hat 2 and wage hat 3 to this box, and we click OK to run the test. And here in model summary, in the line regarding model 2, which is the complete one, we can see that we do not reject the null hypothesis of correct specification because the new variables with the squared and cubic terms were not jointly significant to explain our dependent variable. But to do this, we had to change our linear model to a model which is linear only in the parameters, because we had to change the mean of the dependent variable by applying a logarithmic transformation.